All right, for number 4, it is continuous, so it matches the first requirement. Then we want to look at the left-hand derivative and right-hand derivative. So from the left side, we have a negative slope, but it gets steeper and steeper as we get closer and closer to c, and it's going towards like a vertical line. And in that case, when it's a vertical line, the slope would be undefined, which means the derivative does not exist. Same thing from the right. Here we have a positive slope. As we get closer and closer to c, it gets steeper and steeper. So that's approaching positive infinity from the right side, and negative infinity from the left side. So technically these limits do not exist. Left-hand and right-hand derivatives do not exist, and they're not the same, so this is not differentiable. Right? And we can tell from the graph because there's a sharp point, right? Sharp turn. For number 5, we can see there's a sharp turn here as well, so we can kind of assume that this is not going to be differentiable. But let's look at y again. It is continuous, so if it's the first requirement, left-hand derivative is going to be 0, right, because we have a horizontal line from the left side. And then from the right side, we have a negative slope that gets steeper and steeper. So it doesn't really matter what that slope is. From this side, it's going to be 0. This one's going to be positive. Those don't match up, even though they both exist. It's not going to match up. And then for our last one here, number 6, it's continuous. Slope is positive here. It gets steeper and steeper as we approach c, and that's going to be approaching positive infinity, right? Vertical line. And then from the right side, positive slope gets steeper and steeper. As we approach c, the right-hand derivative is positive infinity. Even though these are the same, this is not differentiable because those one-sided derivatives do not exist, right? Because they're going towards infinity. So we have a vertical tangent line. These are not going to be differentiable at c.